rejected. So, okay, this is one sample t-test. Now we come to independent sample t-test. Okay. So here we have to check the independent sample t-test. So this one is first see the description of the study, case study. So here the example to know whether the salary of male faculty members in private institutions is equal to the salary of the female faculty members. Researcher collected data from 20 male and 20 female faculty members in private institution to know the difference. So independently, the observations on 20 male and 20 females have been taken on their salaries, and we have performed the independent sample t-test. These numbers may differ, but they should not differ much. Now, okay, we come to the independent sample t-test. So, okay, here you can see here we have just coded one as male and two as female, and this is the salary for both the. So you can here either you check the normality for both, since if we are interested in checking the normality, so we should check independently the normality of the data, because we are taking here considering the two groups for the comparison. So 20 observations should be subtracted, should be extracted here, and 20 and then another one, and we should check the normality before performing this independent sample t-test. So we can check by taking these observations, say male. So just I am copying them and I am just putting here. Okay. So now just you go on the variable v when we are just replacing the decimal place. Okay. And say it is say male. And now you just come to the one. Okay. And say we are just putting here. Okay. So now you go to this one as well. And we are 0 and this we are setting as female. Okay. So now we will be checking the normality of this data, but it will consider actually 40 observations and dots are there. So let us see. Go to analyze, then descriptive, then explore, and just we are just clicking on these two observations here and go to plot and then remove it, click on the normality plots with tests and click on OK. So okay, here you can observe both the descriptive statistics for male and female, and description for both the male and female are given in these two tables. And here you can see for male and female we are getting the significant non-significant values, because p values are 0.2, 0.2 for male and female is through Kolmogorov-Smirnov test, and 0.2 and 0.3 for through this Abbeville test. So both by both the tests, the data for female and male both are normal. We can observe here by through box plots. So anyone has any problem? Someone is drawing here some art. Okay, so now let me remove this one and remove this one, or you left it. So now we'll be performing the independent sample t-test. So click on analyze, then go to compare means and go to independent sample t-test. So here salary will be the main variable, while this categorical variable will be the grouping variable, and you have to define group here. So one is for say male,
Sir, please unmute yourself.
So,
Yeah,
okay.
Please share it again.
Okay.
Share the screen.
I think now it is visible.
Yes.
So we have to put the grouping codes. So we have coded 1 for male and 2 for female, as you can check from here. Not performing because we are just okay. So now you may go for the options. So you need to go there and you just click on OK. So you'll see here the independent t test has been performed, and you can see this is the, I mean, descriptive statistics, a mean, standard deviation, and standard error for the mean for male and female. So you can have idea from this descriptive statistics table that this is going to be accepted or rejected. So you may say, you can see, we can observe here that the average salary for female is 39,400, while it is 49,900 for the male. So I think 10,500 is the difference. So it's a good difference. So I think it must be rejected. So okay, there is now, since we are applying independent sample t test, so here one of the assumptions of t distribution is that the variance of both the population is same. So if it is same, then we apply the t test, and if it is not same, then also we apply for the we apply t independent sample t test, but with the adjusted degrees of freedom. So there is a test to test whether the variances of both the population are same or not. There is a famous Leven's test. So we apply here Leven's test, and through Leven's test we see that through p value of Leven's test that it is not significant, because the p value is more than 0.05. It means the variance for both the populations are same. So if it is same, which is showing through this p value, so equal variances assumed is correct. And if it is less than 0.05, then we'll go for the this option, and we will consider the values on the lower line. So here, since p value is greater than 0.05, so we'll consider the first one line. So we will consider this p value, but it is also 0.000. It means it is very much less than 0.05. So the test hypothesis is rejected. The null hypothesis is rejected, and the null hypothesis is that the average salary of both the populations, say for male and female, is same. But through the observation, we can say that it is rejected. It means the average salary of male is not equal to the average salary of female. Okay. Now we come to the pair t-test. So pair t-test, there is a case study. Say ABC University arranged a special faculty development program for one segment of its teachers. The university wants to measure the change in the attitude of its teachers after the FDP, that is faculty development program. For this purpose, it has used a well-designed questionnaire which consists of 10 questions on 5-point scale. Say it is 5-point Likert scale. Rating from 1 to 5. 1 is strongly disagree and 5 is strongly agree. So say strongly disagree, agree, moderately agree, or strongly agree. Say these 5 degrees are there in the category. So the university selected a random sample of 20 teachers, and they have been asked 10 questions on 5-point scale, and we have data, and we will be looking for the result analysis. So here we have say pair t-test training data. So we will be performing the, we will be checking the performance of teacher before the test and after the FDP, before FDP and after FDP. So these are the scores, say before FDP, and these are the scores on after FDP. So we'll be checking the both. So you just go to analyze and then compare mean and go to the paired samples t-test. So one by one you put here, one here is there and another one is there, and you go for the option. So 95% is there, so no need to go there and no need of bootstrapping, and click on OK. So you'll see here the pair one, before faculty members and after faculty member, and paired sample statistic. You can see here, this is the mean observations, mean score before FDP, and this is after FDP, all 20 persons. Same persons are there. That is why it is known as paired, because we are considering the same sample and we are taking observation twice. Some before applying any technique and after applying any technique. So these are the standard deviation and these are the standard error for the means. Now here the test has been applied. Now you can see here it is the correlation between the two, I mean, scores. So it is non-significant. It means almost they are independent. So no, here we consider the null hypothesis that the correlation is 0. It means they are independent. So it is showing here. Now we go for the t-test, and you can see here the p-value for this t-test, pair t-test is 0.000. It means very much less than the 0.05. It means the null hypothesis is rejected. And here the null hypothesis is that there is no effect of FDP. It means before score before FDP and after FDP are same. But the test is saying that it is not so. So the FDP is effective. So this it is concluded that the FDP is effective on the behavior of the, in changing the behavior of the teachers. Okay. Now we come to ANOVA, analysis of variance, and we know that it is extension of t-test where we wish to compare the equality of more than two means, 3 or more. So now we will be, I mean, we have some description of the case study, and then we will be performing the ANOVA table, ANOVA test. Okay, so there is a case study of store promotion. An experiment in which a major department store chain wanted to examine the effect of the level of in-store promotion. The experimenter wants to know the impact of the in-store promotion on sales, whether the in-house or in-store promotion is effective on sale or not. So there are 3 types of promotions there. In-store promotions were varied at 3 levels: high promotion, medium promotion, and low promotion. So we are just wishing that whether these are equally effective or say they have impact on the sale. Okay, so here you can see, observe that we have coded 1 for say high promotion, 2 for medium promotion, and 3 for low promotion. And these are the sales with the low, medium, and high promotions. So now we'll go for the analysis. So go to analyze, then compare means, and go for the one-way ANOVA. Okay. So you just put the here, and you have to say factor here. And contrast. If you wish anything, then click on that. Otherwise, you can go for the postdoc test. If your null hypothesis is rejected, then we have to perform the t-test again pairwise. So this is known as multiple comparison test, or sometimes we call it as postdoc test. So we'll go for say Taki and then click continue. And if you wish any observation, homogeneity of variance test apply, and you wish the descriptive statistics, and you say mean plot, then click on those and you click on OK. So you can see here there is no need of actually this. These are all going to be significant because here okay, there is need of this one. So you can see here that this is the descriptive statistics, high, medium, and low promotion, all 10, 10, 10 observation, and all total 30 observation. These are the mean, these are the standard. Taki, what do you wish to know? Taki is a multiple comparison test. So just for 5 or 10 minutes, we will be considering the questions of these parametric tests. So wait till that, and till then you note down the questions. So these are the standard deviation of the variables, while these are the standard error of the respective means. And these are the upper and lower bounds, and these are minimum and maximum observations. Now this is the homogeneity test of variance, whether the variance for all three observations are same or not. So it is so, because p-value is more than 0.05. Now we come to ANOVA test. Now you can see here, these are the between groups, within group, and you can see here the p-value, f value is this one, and p-value is 0.000. It means the null hypothesis is rejected. It means the average cell for all the promotions are not same. Now, since it has been rejected, so we'll go for the multiple comparison test, postdoc test. So these are the postdocs, since we have applied Taki test here. So Taki HSD test here. So now you can see here the high promotion is compared with all others, high with medium, high with low. So you can see here all are significant. Medium with high and medium with low, all are significant. Low with high and low with medium, all are significant because p values are less than 0.05. And you can have an idea from these descriptive statistics that mean is 93,700, it is 67,900, and it is 40,600. So all are reasonable and considerable differences. So these are not going to be same. So all are significant. If suppose this is 40 and this is 42, so the medium and low would not be the significant, but both will be significant from this one. But all are having significant differences. So all are significant. And this Taki test is also. So you can perform any other multiple comparison test as well. Now you can see here from the graph. These are the low, medium, and high. Income. So you can see here, this is going to be almost 40,000. This is going to be 68,000. This is going to be 90. So this is a very huge difference. Now we have another one which is known as repeated measure ANOVA, which is extension of the pair t-test. So suppose we have a diet plan. So this is a case study. A dietitian introduces new diet chart plan to reduce weight loss. The dietitian took 15 women who considered themselves to be in need of losing weight and put them on this diet for say 3 months, not 2 months. So their weight were measured in kilograms at the start of the diet, and then after 1 month, then after 2 months, then after 3 months. So let us see. Okay, so here these were the weights of 15 women at start, before starting the diet, particular diet. Then after 1 month, this one. Then after 2 months, this one. After 3 months, this one. So now we will perform this repeated measure ANOVA test. So we'll go for the general linear model, not for the, not in compare mean, it is not given there. So we'll go for GLM, general linear model, and we'll go for the repeated measures. So here we are having 4 factors. Base month, then 1, 2, 3. So you have to put 4 here. And you can give us also give the factor name, say diet. This way. And you add. And you can measure the name, say weight. And you define this. So you just click, either you one by one put them here, or you select all and put them here. And you can go for the model. So full factorial, no issue. And okay, you can go for the contrast. So you can define here polynomial, or so polynomial is okay, no need to change. And you go for the plots. So you can diet, and you can plot them whether diet on a horizontal axis and or other things, but no need, you just click. And you can perform the postdoc test if any needed. So you have to define first factor, then we can click on this one. And option, if say diet here, and compare the main effect, and then go for the different observation cells, says descriptive statistics and homogeneity test. Anything else? No need. Okay. You can see here. These are the 4 factors: baseline, month 1, month 2, month 3, and these are the average weight: 102, 93, 85, 69. So all are going to be significant. See here, and which is shown in here. So you can see multivariate test. Pillai's trace, Wilks lambda each applied, all these tests are applied for the internal homogeneity. It means whether the data is homogeneous or not, internal homogeneity, we check through these tests. Now we go for the Motley's test for sphericity. Sphericity is the property, just like the check the homogeneity of the data. A homogeneity of or equality of variance. So here, since we are using more than 2-dimensional data, so we are just checking the sphericity. So here we will be checking whether the variances for all the groups are same or not. So you can see here it is going to be significant because the p-value is less than 0.05. So here it is shown that the variance for all the 4 groups are not same. Now these are the within subject effect. It means within the group, within the baseline, within the 15 women, what are the differences? So here you can see here, and these are the different, these are the MSCs and these are the p-values. So here we can observe from p-values that all are going to be significant, all the groups. Now we are interested in within subjects contrast. So you can see here linear, quadratic, cubic, all the types of graphs or models are applied there, and all are going to be significant. If you are applying the linear model, then it is going to be significant. If you are applying quadratic, it is going to be significant, and cubic model is also significant. So these are the models which we are applying. Now we are interested in between the groups. So this is actually that test in which we are interested, and it is significant because p-value is less than 0.05. It means the average weight for all the 4 months are not same. It means the diet is effective in reducing the weight of the 15 women. So you can see here now first one is compared with the second, third, and 4th month, and you can see all are going to be secondary. It means every month the weight is reduced. So you can see here. This is reported that table level. So now if you have any query, any question, you please ask. No need to write there Taki in between. Yes, if you have any query, you please ask. Dr. Yadav, you open the, allow the candidates, allow the participants for some time, for the while, and we'll be considering the question, then we'll be discussing the non-parametric.
Okay, so I think,
Hello, sir.
yes.
So what is the concept of confidence interval here?
Confidence interval is nothing but if we are not, having some confidence say, on the point estimate. So because if we are estimating the parameter through sample, then it varies from sample to sample there. So that is why there is the concept of standard error there. So is there any interval with some confidence that all the maximum estimates from all the possible samples it is containing? So suppose you are just calculating the height of say 4 persons in out of 20 persons, then you will see the average height for all different or some common 4 peoples are different. So it means the height is varying from sample to sample. So if you are given that same test, you are just checking that no need, you can check, you can apply any of the tests. There are minute difference. This makes hardly difference that which test you are using. No need, you can apply any test.
Sir, I have a question, sir. Like usually अभी तक हम जब भी कोई स्टडी करते थे, मीन निकालते थे, वन सैंपल टी टेस्ट कभी भी कोई हमारे जो कलीग हैं स्टैटिस्टिशियन वो कभी भी नहीं हमसे निकलवाते थे. तो मतलब जरूरत इसकी है क्या एग्जैक्टली? वन सैंपल टी टेस्ट करना ही क्यों है?
वन सैंपल टेस्ट की जरूरत तो वहां पर होती है जहां सिर्फ आप एक ही वेरिएबल, एक ही सैंपल का कुछ चेक करना चाह रहे हैं. मान लीजिए आप चेक करना चाह रहे हैं कि क्या एवरेज हाइट यहाँ पर इस जो सब लोग यहाँ पार्टिसिपेंट है, एवरेज हाइट उनकी 5 फुट 6 इंच है कि नहीं, या 5 फुट 5 इंच है कि नहीं. तो सबका लेंगे और हम कंपेयर करेंगे. तो जो हमारा एक फिक्स्ड वैल्यू रहती है, एज्यूम्ड वैल्यू रहती है, उससे हम कंपेयर करते हैं उसको.
सर जैसे कि हम नॉर्मली हम जितनी भी रिसर्च अभी कर रहे हैं उनमें वन सैंपल टी टेस्ट की जरूरत नहीं पड़ती ना, या नहीं?
जरूरत नहीं पड़ती है क्योंकि हमने 2 से कंपेयर कर रहे हैं मान लीजिए. लेकिन अगर सिंगल के कंपैरिजन की बात आए तो वो कोई एज्यूम्ड ऑब्जर्वेशन.
अच्छा, अगर हम मतलब फॉर एग्जांपल हम ऐसी कोई स्टडी कर रहे हैं जिसमें हम कोई सिंगल मीन निकाल रहे हैं और हम प्रिज्यूम कर रहे हैं कि उसका मीन क्या होगा. जैसे हमने ये कहा कि बच्चों का वेट एवरेज 5 साल के बच्चे का 10 किलो होना चाहिए, 15 किलो होना चाहिए, और 15 है या नहीं है. हाँ, ऐसी तो कोई स्टडी कर रहे हैं तो
आइडियली जैसे हाँ यही आप करते हैं कि जैसे हम वेट चार्ट से देखते हैं कि इस साल पे इतना होना चाहिए, तो उसी साल के उतने लोगों का हम देखेंगे और चेक करेंगे कि वो है सही है कि नहीं सही.
तो ऐसे में वन सैंपल टी टेस्ट लगाना.
हाँ, वहां पर
तो सर फिर उसको जो पॉपुलेशन मीन है वो कहाँ से आएगा? वो फिर हम
पॉपुलेशन मीन वही तो आपने रखा है, प्रायर डिसाइड रहता है, इसीलिए तो उसको एज्यूम मीन कहते हैं. आपने रख तो दिया कि 15 किलो होना चाहिए, जो 15 किलो कहाँ.
सर कल वाली पीपीटी में ना जेड टेस्ट भी लिखा हुआ था जो हमें शेयर की गई, जिसमें लिखा
जेड टेस्ट क्या होता है? ये स्टैंडर्ड नॉर्मल टेस्ट होता है, उसमें कुछ नहीं, स्टैंडर्डाइजेशन कर देते हैं नॉर्मल डिस्ट्रीब्यूशन.
सर
डिस्ट्रीब्यूशन है सर. देखिए सैम्पलिंग डिस्ट्रीब्यूशन और थ्योरेटिकल डिस्ट्रीब्यूशन में डिफरेंस रहता है ना. जो उसका स्टैंडर्डाइजेशन करते हैं वो जेड है, नॉर्मल का ही.
Actually, please speak in English because there are some South Indian participants.
Okay, so Z test is nothing but it is standardization of the normal test and it is sampling distribution. So if we are just taking the large sample, then all T tests converts into Z tests.
Sir, there was a question. Sir, how Z test will be converted to T test?
T test, say there are some assumptions for applying or conditions for applying the test. We are just not converting any test, but since all the theoretical as well as sampling distributions approaches normal as we increase the sample size. So here jet, if you wish to convert say jet test into t test, so you have to reduce the size. So since t test is the exact sampling test or say small sample test, so if you are applying the sample, if you are taking the sample say less than 30, then we will be applying t test. Otherwise, if you are considering the large sample, then we will be applying the t test there. Yes, z test there.
Sir, एक request और there is a request, sir. Since ANOVA is covered a little early, if there is a pre-recorded session of any previous year, because you taught very nicely. So if we can get some details of ANOVA, any PPT or any.
Yeah, we share the PPT, sir, who is talking about this parametric.
Because these words were quite new for us, like Turkey and all these. So if you can provide some content or some reference.
Okay. Just I am having this one PPT. I will share this one.
Thank
Sir,
you,
sir, I want to ask
Sir,
you.
I have a question.
Sir,
Don't worry, can please ask question one by one, and we will share the data sets and the PPT also after the completion of the live class. Okay, and recording as well as. So, don't.
Sir, I have a question with regard to the normal distribution curve.
Okay.
Usually it should be like a bell-shaped curve, but in the examples that you have shown in the independent t-test and all, it is upward sloping. And you are saying that the null hypothesis is accepted because it is normal. So how it is the shape of the curve?
No, actually that is not on the usual scale. That is taken on the say logarithmic scale. So in log scale, it should be a straight line.
Yeah, okay. So one more thing, sir, like how you have described the case. Similarly, you also give us the how to report the results.
Definitely.
In a paragraph manner.
Yeah. So
basically,
you have to see whether the p value is greater than or less than the 0.05 to check whether your hypothesis is going to be significant or not.
But there are number of tables, no, sir. Out in the output window, there are number of
tables. You can explain by your own. You just put that t value is this and with this degree of freedom, and since p value is this, so the hypothesis is rejected, and the hypothesis is rejected, it means the test is going to be significant this way. So whichever you are using the test, so you have to explain accordingly. So if you are you just give me example, in any example I will write down the interpretation.
Yeah.
Sir, I have a question.
If you have any query any time, you may ask me or Dr. Yadav, and we will give you the solution.
Thank you.
Sir, I have a question. When to use Z test, F test, or chi-square test?
Okay, very nice question. But as we have discussed, there are, assumptions and testing hypotheses for different things. If you are testing, say, t-test, then there are applications of these distributions, sampling distributions. So there are two types of sampling distributions: large sampling distribution, which is Z distribution, and small sampling distribution, or sometimes called exact sampling distribution, that is T, F, and chi-square. So there are applications of T distribution. So significant of independent sample t-test. It means we wish to check the equality of two means of the two group, and pair t-test. Then if we wish to check the correlation, whether they are correlated or not, and if we are checking the regression where they are having independent variable is having impact on the dependent or not, by which rate. So these are the applications of t-test. Similarly, we are having some applications of chi-square as well. If we wish to check the independence of attributes, then we will be applying the chi-square test there. Similarly, if we check just like we are checking we are testing the equality of two, say, means, and if we are interested in checking the equality of, say, two variances, then there we will apply the F test. And if we are interested in, say, significance of variance, then we will be applying the chi-square test. So there are certain, very clearly written applications of these distributions. So there we will be applying according to situation and according to the hypothesis.
Okay, sir. Thank you.
Sir, I have
Sir,
a
I have
question.
a question, sir.
Hello, sir, I have a query.
In chi-square test, no cell frequency should be less than 5. If it is so, then we do we apply pooling there. We pool the less than 5 frequency to 1 cell. And it
Sir,
is
I
done.
have a
It is
question.
done because of the to maintain the continuity of the distribution. Someone is
Sir, I have a very
typing here.
basic.
Sir, I have a
Count,
quick
please.
So I have a
question.
basic question regarding the formulation of null hypothesis. So for example, if I want to compare the effect of age on income, so will I start my null hypothesis by saying that there is no significant relation between age and income?
Definitely. Whenever you are applying chi-square, you are using the independent sample t-test. So null hypothesis is always that it makes no difference. So we call that null hypothesis means the hypothesis of no difference. So where we already say that there is no impact of the two attributes. The two attributes are not associated at all.
That's
no
always
impact.
Thank you, sir.
Sir, I have a question.
Sir, I have a
Sir, I have a question. If we are doing a CAP study and we are analyzing our data from the scale like weakly agree to the strongly agree, as you have given one example for the woman before the test and after the test. So how to interpret that data on the scale and which test we should use on it?
Say that we are going to discuss.
Okay.
If you are having categorical data, if you are dealing with the say attributes or characteristics or qualitative data, then we use the equivalent non-parametric test. Say equivalent to independent sample t-test, we apply the equivalent. We use there the equivalence of this independent sample t-test. So we are just going to discuss different tests. So we are having so many non-parametric tests there, and we will be discussing and we will be comparing and we will be just I will be discussing to which parametric test this one test is equivalent.
Sir, suppose we don't have population mean.
test.
Sir, suppose we don't have population mean and I want to do one study that can design that there are in this population, suppose in children like 10 to 15 years, if I have done few studies like suppose echocardiography and I want to define their parameter, then which test I can apply in them? Suppose
So
I
there in such situation, if we are having some observations on say interval or say this type, so there we apply the data will not be going to be normal at all. So we will be applying the non-parametric test and say some more robust measures. So median will be applied there.
Median, sir. Actually, suppose I have adult data, but there is no any pediatric data, and I want to conclude that pediatric findings are like this in this population.
So that way we will have to make some say, but if you are not having cases at all.
No, I do have cases. Suppose, for example,
then we will make different categories. We will make the intervals. We will make the categories below 15 and say from 15 to say 30 or 20, say 20 to 25, 25 to 30. This way we will make the.
No, sir, not like that. Suppose I am giving you example. I have studied children of thalassemia and then cardiac finding. Okay, but there is no any adult cardiac dystrophy of diastolic function and relevant echocardiographic finding. And I have studied it, but there is no standard pediatric parametric, only adult parametric is available. Then how can I conclude that these findings are normal or abnormal? Or I just...
For the pediatric.
Yes, sir.
So how can we actually for this cause and effect relation? So we have to see the causation first. So there is very famous test that is known as the Granger causality test. So Granger causality test will have to apply there, and then we can establish the causation. And then I don't think how we'll be studying or establishing the norms for the different population. from we are not having data.
Yeah, it is very
Sir, I
difficult.
have.
Is
Sir,
there
I
any
have.
relationship between confidence interval and p-value?
Sorry.
Sir, is there any relationship between confidence interval and p-value?
Confidence interval and p-value.
So if you wish to this, as such, there is no relationship because we are just making the confidence interval for that the values of the statistic under consideration, and p-value tells whether the test is significant or whether these values are going to be significant or not.
Do we always take confidence interval at 95%?
Generally, we take the 95% confidence interval, but you may take 90 as well. You can take 99% as well. So that interval will be made there. If you are making 99% confidence interval, it means 99% of the all possible values of these statistics from all possible samples will lie in that prescribed interval. Okay, so that is not associated with the significance of the values. Whether it is significant, it will be made there. But it is not significant, it will be made there. So it is associated with the values of the statistic only.
Sir, what confidence interval we should take? 95 or
95%. Always we take 95%. It is on safer side. 95% confidence.
Sir, in case
Sir, I have a question. Like always, there should be a rejection of the null hypothesis to be significant.
Yeah. If your hypothesis is significant, it means we are rejecting the null hypothesis.
Sir, I have a question. In case of ANOVA, you have showed that there first we apply Levine test in ANOVA, and in your
no, not Levine's test on ANOVA. It is applied on the t-test, and there we apply for test for sphericity.
Okay, sir. So, sir, in ANOVA, there was this homogeneity of variance test. So in that, if the null hypothesis is rejected, then what we should do?
Because we go for the multiple comparison test.
Okay, sir.
Sir, you're giving a very.
Why these tests are known as post-hoc after that.
Sir, if the organizers permit, sir, if the organizers permit, can you talk us on the parametric tests? Because I was around yesterday and I did not understand anything at all. If the organizers permit, can you please give a talk now on the parametric tests? I'm sure many of us will have the same view.
But I have been assigned non-parametric tests. So I think while discussing the non-parametric test, I will also discuss the parametric test.
Up to the organizer. We were.
Sir, I have a query. In your presentation, you mentioned the core in your PPT. That was, I think, so to check the effect of training or effect of FDP. What do you mean by score, and how can we calculate if even you have some variables which was only
we have performed some tests. These are score through tests.
So when we go to a post-hoc test, sir?
When the null hypothesis is rejected. So we check which pair of treatment or say pair of observation is going to be significant for the rejection of the hypothesis. So there we apply the post-hoc test.
Sir, I have a question regarding the non-parametric ANOVA, that is the Kruskal Wallis, where I am using the percent data for that. So should it be transformed first, then I can go for the non-parametric ANOVA Kruskal Wallis, or is it the simple way just I can do that from the percent data also?
You can apply from Likert scale data as well.
Pardon, sir?
You can apply from the category scores as well.
Sir, I joined class at 6 o'clock sharp, and what I understand, you was talking about parametric test only. And I don't know, suddenly there is a question about Kruskal Wallis.
Just
rather now I am confused.
Actually, I have been assigned the discussion about the non-parametric
I think you are
test,
not even
but
able
I
to
was
start your
told
talk now.
to discuss the hands-on on the parametric test.
So I think you are not able to start your talk, I think, even by now, sir. So,
Doctor, excuse me,
please,
Doctor.
please let me start the non-parametric test, and
Yes,
later
sir,
we will be
please, sir.
discussing both type of questions.
Yes, sir. Otherwise, sir, we will be.
Query. Sir, I have a query regarding the post-hoc test. Sir, every time post-hoc test is necessary after ANOVA. Sir, applying
If
ANOVA.
your hypothesis is rejected, madam, you see, if it is accepted,
Yes,
there is no need of a post-hoc test. If it is rejected, then only we have no way to do that. So either you do pairwise, you apply the test, t-test, and the simultaneous. This is the application say of simultaneous pairwise on t-test for different pairs.
Dr. Dharmen, I
Thank
think
you, sir. Thank you.
Dr. Askado should start this our
Thank you, sir.
Assigned lecture, no? Dr. Dharmen?
I think now I should start non-parametric test, na?
Yes, sir. Yes, Doctor, sir.
Okay.
Please start, no? Otherwise it will be delayed.
We will not be able to finish in time.
Yeah. Time can be expanded, but
Yes. We can discuss it later.
We have some, sir. We have some other assignment.
Dear participant, please don't write anything on the screen. Dear participant, please don't write
all
anything.
participants are requested to please not write anything in over this slide. So please remove. Organizers are requested to remove these letters. You will be given time to ask the things, and we are here to discuss the things. So please don't write anything in between. Otherwise, we'll be disturbed and we'll be deviated. Yo, someone has started. Okay. So non-parametric, as we know, there are these are known as non-parametric since we have no assumptions regarding the parameters. So a parametric statistical test is one that makes assumptions about the parameters of the population distribution. That is, first one is that the parent population should be normally distributed. But in non-parametric, we don't have such type of any assumption that the parent population should be normally distributed. From which one's data are drawn, it must be normally distributed for the parametric test to be valid. And a non-parametric test is one that makes no such assumptions. In this strict sense, non-parametric is essentially a null category, since virtually all statistical tests assume one thing or another about the properties of the source population. Basically, we consider there that the population is normally distributed. And here in non-parametric, we don't have such type of assumptions that it is normally distributed, and rather we apply non-parametric for the non-normal populations. So now the question arises, which one is more powerful? Obviously, parametric tests are more powerful, because there we use the actual observations, and here we use only the categories. So non-parametric tests, statistical procedures are less powerful because they use less information in their calculations. Sometimes we use, most of the time we use the ranks. For example, a parametric correlation uses information about the mean and deviation from the mean, while a non-parametric correlation will use only the ordinal positions of the pair of scores. That is, we apply the ranks in, say, Karl Pearson rank correlation, Spearman rank correlation, and in Karl Pearson cross-sectional correlation, we apply the actual values of the variables, while in Spearman rank correlation, which is non-parametric test, we apply only the ranks. So these are the assumptions regarding parametric test, which someone was asking for. So the observation must be independent. The observation must be normally distributed. It means the parent population should be normally distributed. and these population must have the same variance, that is homogeneity of variance. And the means of these normal and homoscedastic population must be linear combination of the effect due to column or host. Environmental effect should be additive in nature. This way. And there are few and weaker assumptions regarding the non-parametric tests. Certain assumptions are associated with most non-parametric statistical tests, such as observations should be independent, one thing, and the lower order moment should exist, and one more thing, the variable should be continuous. So there are three assumptions there, but these are fewer and weaker in comparison to those that of the parametric tests. Okay, so these are some of the advantages of non-parametric tests, that probability statement obtained from most non-parametric statistical tests are exact probabilities, regardless of the shape of the population. That is, here we are not considering the symmetricity of the data from which the random sample was drawn. And if sample size is small, say less than 6 or lesser, so we have no, option to use any test rather than the non-parametric test. So whenever you are having observations 6 or lesser, so you have to apply their non-parametric tests. And these are easier to learn and apply than the parametric tests. And these are based on the model that specifies very general conditions. No specific form of the distribution from which the sample was drawn is needed. So it may be, different from normal distribution only. So hence non-parametric tests are also, these non-parametric tests are also known as the distribution free test, because we don't bother about the form of the distribution of the variable under consideration. Now, but at the same time, there are so much disadvantages of these non-parametric tests. That is why in comparison to say parametric tests, these are not so much powerful. So losing precision, wasteful of data, we lose precision because of the ranks only. We are not using the actual observations. Suppose the score of any class, say in any test, lie in between say 60 to 70, but someone is getting 90 marks. But if you are just applying the rank, then the first rank will be given to 90, while the second rank will be given to 60. And there is a difference of say 30, but rank, there is a difference of rank only 1. So this way we will be losing the precision. And low power, obviously, and false sense of security. We are just saying that it is secure, but we are using this 90 and then 60 and say 65, say 60 and then 59, say 65, 58. And we are just applying the ranks 1, 2, 3 and so on. So we are having just false sense of security that we are applying the, we are strongly analyzing the things. And lack of software, but now this should be omitted there. There are, SPSS is there to analyze the non-parametric tests, and testing distributions only. Here we test only distribution, whether it is normal or non-normal. So we don't go for testing any distribution. So this is one of the drawback, because we are not checking which distribution the random variable is following, but only we see whether it is normal or non-normal. So all the distributions come into the category of non-normal other than normal distribution. So higher order interactions not dealt with, we only deal with the lower order. So we talk about the lower order movements. And parametric models are more efficient if data permit. So if you are just, increasing the data, then parametric models or parametric tests are more efficient and more powerful. And it is difficult to compute by hand for large samples. Very large formulas are there to calculate the things, so it is very hard to calculate by hand. So tables are not widely available for non-parametric tests, but now these are available. So in cases where a parametric test would be appropriate, non-parametric tests have less power. Definitely If we have a considerably, size of the sample, then we will be applying the non-parametric test, not the non-parametric test. And if we are not having, much data, then we'll be applying the non-parametric test. Someone is drawing very good drawing. So in other words, a large sample size can be required to draw conclusion with the same degree of confidence. It means if we are not in condition to get the conclusion on the basis of the non-parametric test, so we have to increase the sample size and we will apply the equivalent parametric test there to get the better efficient estimate or conclusion or inference about the parameter or population under consideration. These are few points to be noted down, that the inferences drawn from the test based on the parametric test such as T, F and chi-square may be seriously affected when the parent population is not normal. So that is why while doing the hands-on, I was saying that first we have to check the normality of the data before applying any parametric test. The adverse effect could be more when sample size is small and you are applying the parametric test. So thus, when there is doubt about the distribution of the parent population, so non-parametric method should be applied there. If you have that the data is not normal, then you apply the non-parametric test. So in many situations, particularly in social and behavioral sciences, observations are difficult or impossible to take on numerical scale, since we are dealing with the, say, attributes, characteristics, qualitative data. So a suitable non-parametric test is an alternative under such situation. We use the equivalent non-parametric test to deal with the characteristics or say attributes or say qualitative data. Now this is tree chart for the non-parametric test, say non-parametric test, and you can see here test for the relationship between variables. So it is chi-square test, Spearman rank correlation, binomial test, run test, and one sample Kolmogorov-Smirnov test. So if you have any query, any question, please note it down. Otherwise we will be disturbed. So test of difference between groups. Here we are just within the group, we are calculating the relationship, and here we are calculating the differences between groups. Now the cases may be of two types, two group case and independent groups and dependent groups. So this may be of two variable case and say two group case and more than two groups. Same with the dependent sample, two group case and more than two group case. So two groups, two variable, Mann Whitney U test. This is equivalent to the independent sample T test. And these are some more equivalent tests: Kolmogorov-Smirnov Z test, Wald-Wolf run test, and Moses extreme reactions. And for the pair of observations, this is for more than two variables. So this is median test, Kruskal Wallis test, and John Hiret test. So here among these three, Kruskal Wallis test is more effective and it is more efficient, and this is equivalent to ANOVA, one-way ANOVA. Now we come to dependent. These were for the independent, two and more than two groups. Now we come to dependent samples, two or more than two groups. So for the two group case, it is Wilcoxon signed rank test, McNamara test, marginal homogeneity and sign test. Among these, Wilcoxon signed rank test is more efficient, so we use is as the alternative of the pair T test. Now if we are dealing with the say more than two pair groups, more than two repeated groups, so this is going to be alternative of the repeated measure ANOVA. And here we use these three tests: Cochrane Q test, Friedman ANOVA, and Friedman test, and Kendall's W. So among these, Friedman ANOVA is widely used because it is more efficient, and so this is the alternative, or say non-parametric test equivalent to the repeated measure ANOVA. Now we come to one sample t-test. Sorry, one sample test. We'll not be speaking any more T here because we are dealing with the non-parametric test only. So say equivalent to the significance of mean, yeah, one sample t-test. So binomial test is there, run test is there, and one sample Kolmogorov smooth test is there, case test. So this is alternative to the one sample t-test. That is, the particular sample come from a particular distribution. Say we wish to check the, or say we are just checking the fitting of the distribution. So we will be testing it through one sample Kolmogorov smooth test. Now two independent sample test. So the non-parametric for two independent sample are useful to determining whether or not the values of a particular variable differ between two groups. This is especially true when the assumptions of T are not met, and assumptions of T are that the parent population should be normally distributed, variance should be unknown, and sample should be small. But here the first one assumption is, if the first one assumption is violated, that is the data is not normal, so we apply the equivalent test, and that is Mann Whitney U test, or it is sometimes called Wilcoxon's rank sum test. So, and these are also the equivalent test. The two sample Kolmogorov smooth test or Wald-Wilford run test and extreme observation. Here see, as the role of mean is there in the parametric test, that role is played by the median here in non-parametric test. Because here we are dealing with the categorical data only. So our say then we are using the more robust measure of central tendency, and that is median. So median plays the same role in non-parametric test as the mean or arithmetic mean plays in the parametric test. Now here, say here we are having an example, say data for binomial, run test, and case, all the tests are two sample independent sample tests. So here we are having some male and female, say 10 male and 10 female, say, and we have coded one for male and two for female, and these are their score, say some in any test, say, and we will test to whether the average score or say median score for male is equal to median score for the female. So we will be applying the these tests in say non-parametric way. And so we will go to in SPSS how to perform the non-parametric test. We will go to analyze, then go to non-parametric test, and then go to legacy dialogues. There all non-parametric tests will be displayed there. You go for the one sample case test, or two sample independent test, or say binomial test, or say run test, whichever you wish. So suppose here we are checking the independent of two groups, that is the score for male and score for female are same. So we'll go to two independent samples. So such type of dialog box will be opened there. Two independent sample test. So we'll say we are checking the, say the score here, but here there is another example of cholesterol, say male female. So we are just this is the score. So we will put here this is test variable, and grouping variable will be defined here as we have defined in T, in case of independent sample T test. And you just click on Mann Whitney U test and just click on OK, and you will get the analysis. So this way we will define group here, one for male and two for female, say, and then one and two. This way it will be filled up here, and then you can go for the descriptive statistics as well, and you can calculate the quartiles as well, and then click on OK. So this way the analysis will be displayed as we have done in parametric case. So this is the descriptive statistics table. Say here, there are 40 persons, cholesterol concentration of 40 persons. So this is the average of the score of cholesterol concentration, and this is the standard deviation, and these are minimum, maximum, and these are the percentiles. So here you can see the for 40, all 40 groups you can see here. 1, 2. So here this we don't bother about this because this is only code. This is codes to perform the test. So we will not be discussing these things because these are the codes only 1, 2, 1, 2, 1, 2, 1 for male and 2 for females. Now this is Mann Whitney U test output here. You say here this is say 40. The example is that the 40 persons are there and 20 have been given some special diet and 20 have been put on say exercise to reduce the cholesterol concentration, and their mean ranks are these, and their ranks some are 500 and 320. So you can see here from mean score, mean ranks that this is going to be significant. Now this is the test for the equality of median of two groups. So you can see here the p-value is for the two-tailed, it is p-value is 0.014, which is less than 0.05. So it is sorry, significant. It means there is difference in the cholesterol concentration of the two groups, one having a special diet and the another one having the particular exercise. Now test for two related samples, that is equivalent to pair t-test. So as we have discussed, it is Wilcoxon signed rank test, McNamara test, marginal homogeneity, and sign test. But among these, this Wilcoxon signed rank test is more efficient, so we use this one. And what we do, say here we are having some related observations. Say these are the age and these are say stages of some cancer patient, and these are the their lives. We have survival of the patient, say for no longer than the week, and for 2 weeks, 4 weeks, 6 weeks, this way. So how to apply this in SPSS? These are the assumptions as we have made in for the parametric test as well. Here we see only 2-3 things, that the distribution is not normal and the observations are independent, and third one is that the variable under consideration is continuous. Only 3 assumptions there. Now how to perform this test in non-parametrics? By the same fashion, we'll click on the analyze the non-parametric test legacy dialogues, and we'll go to two related samples, and say here you just say put one variable and another one, as we have done in the case of parametric test, and you just click on the Wilcoxon signed rank test and you click on OK. So these are the descriptive statistics, their means. So these are say pain level for chemotherapy, say SPSS, similarly, assumptions are similar type, 3 assumptions are there. And we'll be performing this in SPSS as we go to analyze, then non-parametric test, then legacy dialogues, and we'll go for K independent samples, K independent sample test. And so this dialog box will be opened here. You just click the variable here and the grouping variable, the category here. So first one will be here, and this second one is here. So we have to, since we are dealing here more than 2 groups, so you have to just define the range, say minimum is 1 and maximum is 3 if we are dealing with the 3 groups. So this way you can define descriptive statistics, and you can say here we have considered another example and displayed another example here. So here we are just giving 3, say, pain relieving drugs to 20 persons, and we just check whether the pain score for median pain score for all the groups are same or not. So this is drug A, drug B, and drug C, and these are the mean ranks. So here we can have idea that the third one, drug C, is going to be significant different from these two. These are very close to each other, but this one is having some reasonable difference. So here, because of this score only, the test is rejected. So here you can see the p-value is less than 0.05. So the test is rejected. Now we will be performing the post-hoc test, that is multiple comparison test, and there we will see these two will be non-significant, while this one will be significant with the first one as well as with the second one. Now the Friedman ANOVA, which is the equivalent non-parametric test of the repeated measure ANOVA. So assumptions are same as we do, that the parent population should not be normally distributed, observation should be independent, and the variable should be continuous. This is example be different in this display while doing analysis. So a researcher wants to examine whether music has an effect on the perceived psychological effort required to perform an exercise session. The independent variable is perceived efforts to perform exercise, and the dependent variable, and the independent variable is music type, which consists of 3 groups, say no music, classical music, and dance music. So to test whether music has an effect on the perceived psychological effort required performing an exercise session, doing mathematics or say doing drawing, say, or other thing, the researcher recruited 20 runners who each ran 3 times on the treadmill for 30 minutes. For consistency, the treadmill speed was the same for all 3 runs. In a random order, each subject ran first listening no music, listening classical music, and listening dance music. At the end of each run, subjects were asked to score how hard the running session felt on the score on 10-point scale. 1 being easy and 10 being extremely hard. So a Friedman test was then carried out to see if there were differences in perceived efforts based on the music type, because all same candidates were taken for all 3 trials, 3 type of music. So here we have repeated just observations. So this is the case of repeated measure ANOVA, but for the non-parametric case, because we have considered the score on the 10-point scale, so equivalent to that repeated measure ANOVA, there is Friedman ANOVA or Friedman test. So these are the persons, and say these are their scores with no music, with classical music, and with dance music out of 10. How to perform this in SPSS? So we'll go to analyze non-parametric test, legacy dialogues, and then for the K related samples. And then here we have 3 types of scores with no music, with classical music, with dance music. Put all here in test variable and just click on Friedman ANOVA and click on OK. So you can see these are the descriptive scores, descriptive statistics. 12% are there, and these are the their percentiles. Now see here, these are the mean scores: 2.3, 2.1, and 1.4. So this is very, I mean, close to each other, but this is, I mean, different from these two. So it must be rejected. Yeah, the p-value is 0.02, which is less than 0.05. So the null hypothesis is rejected here, and we'll go for the multiple comparison test. Post that test. Now, how to apply chi-square test as well? So to apply chi-square test in say SPSS, we will be using this analyze then descriptive statistics and go on crash tabs. So this way you will be looking this I mean dialog box. So you put one categorical variable here and another categorical variable here and go for the statistics, and you just click on okay, this way. And if you wish any statistics, you can go for the say Phi and Kramer's V, or say all other things. Otherwise, you click on continue and click on OK. If you wish to see some observations, so you can click on observed, expected, or both, this way. And you are just putting the observation in whether ascending order or say descending order. So you can click and this way this will be given here cross tab table. So here is gender, male and female, and these are the I mean scores, and along with their percentage 16, which like books, 24 out of 40, 16 like reading books, and 24 like reading online, male, and similarly female, 13 female with books and 27 online. So this way you can see here 29 total overall, 29 with books and 51 online learning. So here we wish to check whether the learning medium is independent of the gender or not, whether learning medium is gender specific, whether gender is independent of the learning medium or not. So now you can see here, these are the tests, different tests, say Pearson chi-square, continuity correlation, likelihood ratio, Fisher's exact test, so many tests. And you can see here, these are the significant value. So here all p-values for all the tests are showing that the test is non-significant. It means because p-value is greater than 0.05 for every test. So it means the two attributes are independent of each other. It means gender is independent of the learning medium. So there is no impact of learning medium on gender, or say gender on learning medium. So this way we will be applying this. So these are. So here through this example, we will be checking whether I mean education is dependent with the associated with the gender or not, whether it is gender specific or not. So we have taken some male and female. We have coded one for male and two for female, and these are high school, intermediate, UG, PG, high school, intermediate, UG and PG. And we have coded one for high school, two for intermediate, three for UG, and four for PG. And so this was all about, I mean, say this non-parametric tests. Now we will be doing one by one hands-on. So let me check the case first one. This is I mean Mann Whitney U test. So here we have a case study of depression. So psychiatrist might collect data to investigate the depressant effects of certain recreational drugs. He tested 30 clubbers in all. 15 were given tablets to take on a Monday night and 15 were allowed to drink syrup. Levels of depression were measured using the tested scale the day after Tuesday and Friday, after Monday after that. So these are the scores given here. Mann Whitney U test. Okay. So here we will be performing the one sample test as well. Suppose if you wish to test whether this is following a particular distribution or not. And one more thing before performing this, I mean non-parametric test as well. So we have to check for I mean normality. But here we have just taken I mean coding is applied there. Okay, so tablet and syrup. So tablet and syrup for 15%. So to check the normality or non-normality, we have to I mean extract these observations 2020 separately. So you can say this way, just we are taking the 20% here. Here just we are checking the normality, so we'll go to analyze and discrete statistics and for the explore, and we will apply this one here and go for the plot and actually this is showing that this is going to be normal. So we must take the data. So here we can apply the parametric test, but this should be less than 0.05. But we through median we can see observe that this is going to be non-normal because it must be in middle of this bar. So okay, every time I have to put it here and there. Okay, so let it delete, and now so now go to analyze and then go to non-parametric test, go to legacy deluxe, and you can go for the one sample test as well. So suppose in this one we wish to check the normal, uniform, Poisson, exponential, whichever you wish. You can click on this one. You can see whether this is going to be significant or not. So it is non-significant. It means it is normal distributed. And if you wish to see this, whether this is, I mean, if you are, I mean, checking whether it is following some another distribution, not normal, say uniform, or say exponential, or say Poisson, so click on it. So it is significant. But this is going to be non-significant. So this one is Poisson distribution. It is little bit, it is following Poisson distribution and normal distribution, but not following these two distributions, exponential and say uniform. So this way you can check whether your distribution is following a particular distribution or your variable is following a particular distribution or not. Now we come to independent sample test. So we go for the non-parametric, then the legacy dialog, and go to two independent sample test. So we'll be performing these two for here. So these are the Tuesday persons, and these are for the Friday. For we are just repeating this. So here we have to check for the only one. If we are checking independent, because we have taken 20% with the tablet and 20% with the syrup, and here we have taken repeated the observations. So repeated measure pair T equivalent to pair T test. So Wilcoxon signed rank test will be applied there. So now grouping variable is drug type of drug, and we have to define one for tablet and two for say syrup. And we are just using this Mann Whitney U test, and you just click on that. So you can see here these are the mean ranks. It is 17 and it is 13, so there is a difference. And but this, this is saying that there is no difference. So here we can say that the p value is more than 0.05. It is 0.203, and so the test is not significant. It means the tablet as well as syrup are equally effective. The two hardly makes the difference. Okay. Now we come to pair T tests, say campaigning. Marketing campaigning. To test the marketing campaign, the researcher took 15 retail outlets who considered being in need of increasing sales and putting them on this campaign for 2 months. Their sales were measured in millions at the start of the campaign, and then after 1 month, and then after 2 months. It means we are taking 3 observations. So this will be the case of if you are taking 3 observations, then this will be the case of repeated measure ANOVA. So here we have to take the say coffee case. Only 2. The Kolmogorov-Smoot test we have to apply here. We are taking how many per day cases? A scientist has discovered the caffeine consumption linked to higher heart rate. Research took 40 participants and split them into 4 groups. So here if we are dealing with the 4 groups, this is the case of repeated measure. So we can here take for the 2 case only, for the 2 repeated measures only. But here we have taken 3. If you are taking 2, then you can go for the 2 as well. So we'll be using 2 for. So we'll go to non-parametric test, legacy dialogues, and we'll go for the 2 related samples. So we'll be putting say start 1 and then first one. And you can go for the no need of it. You go for the option. You can click on descriptive and quartiles you can have. And just it Wilcoxon signed rank sim test, and click on OK. So you can see here at the start of the campaign, the mean sale score over this one, and it was after 1 month it is 81. Now you can say calculate the signs, positive, negative, and tight. So there is no tight case. 8 with negative ranks and 7 with positive ranks. and their mean ranks are 8.1 and 7.8. Now we come to the test statistics. Here the test is applied there. So you can see here the p-value is 0.77. It means the null hypothesis is not rejected, it is accepted. And the null hypothesis is that there is no effect of campaign on the cell. So this example is showing that there is no impact of the campaigning on the cell. And if we are applying this all the three, then this will be the case of repeated measure ANOVA non-parametric case, that is Friedman ANOVA. But we are having some another example and we will be discussing that. So here is example of coffee. Scientists had discovered that the caffeine consumption linked to the higher heart rate. The researcher took 40 participants and split them into 4 groups that varied in the number of caffeine consumption. The first group was a control group and had no coffee at all per day. That is none in the whole month. None in the whole month. The second group had 1 cup coffee per day. The third group had 2 cup coffee per day, and the final 4th group had 4 cup coffee per day. At the end of the month, all of the participants were measured their heart rates. So, okay. So here we are having, scores. Say we have coded 1 for 1 coffee, 2 for 2 coffee, 3 for 3, and 4 for 4. Let's say 1 for no coffee, 2 for 1 coffee, and 3 for 2 coffee, and 2 cup of coffee per day, and 3 for 2 cup of coffee, and 4 for 4 cup of coffee. And these are the heart rates after end of the month, at the end of the month. So now what we'll do, we'll go to analyze, then compare non-parametric test, then go to legacy dialogues and go for the K related sample. So heart rate is there, and for the statistics, say descriptive, area, continue, and Friedman is already by default tick there, and why this OK is not highlighted here? Okay, so you have to put all both the variables at one place. Okay, so you can see here, these are the descriptive statistics, heart rate and coffee consumption, but this is the coding only, so we don't need of this. So I was not putting that into the analysis, but it was needed for the programming. So heart rate, these are the mean score, and standard deviation, minimum, maximum, these are the percentiles, and you can see here, these are the ranks. 1 for heart rate, mean rank 2, and coffee consumption, that is 1. So no need of this one, we only need this one. Here we see p-value is less than 0.05, that is 0.000. So it is very much less than 0.05. It means that the test is significant. It means the coffee consumption do have impact on the heart rate. Now the last one, how to perform this chi-square test. Okay. So here we are interested in knowing whether the two attributes, that is gender and education, are independent to each other or they are associated to each other. Whether education is gender specific or not. So we have taken all these 60 persons and in 4 categories with high school, intermediate, UG and PG, and we have taken 30 male and 30 female. So now we will be performing this chi-square test to check the independence of attributes. So we'll click on analyze, then we go to descriptive statistics, and then there we'll go for the cross type. So let's keep it here. We go to analyze, then compare means, no, descriptive, and go to cross types. So one is here, serial number, no need serial number, gender is here, and education is here. And go to the statistic, you can calculate the chi-square, you can correlation, you can see different other things, and click OK. Okay. Display the clustered bar chart, you can click on this one as well, and click on it. So this way you can see here, these are the different counts, and these are the chi-square tests. So you can see here all the chi-square tests are going to be non-significant. It means the two attributes are independent to each other. The two attributes, education is not gender specific, it is independent of the gender. This is going to be for male and female, high school, intermediate, UG and PG. So this way you can check whether your two attributes are say more than two attributes through the contingency table is going to be significant or not. So this was all about the non-parametric tests. Now if you have any query, any question, you please ask.
In case of chi-square test, if the expected value is less than 5, you said you have to do some cooling effect or something. Can you please explain?
Pooling. To maintain the continuity, since it is a continuous distribution, so to maintain the continuity, we suppose we in any category the frequency is say 4, and then another it is 2, say 1. So all will be pooled and will be put at the cell frequency at 4. So 4 plus 2, it means 6, and 1 7. So 7 will be put there.
Sir, excuse me, sir. I have a question.
Sir, how to perform Mann candle?
If null hypothesis is rejected in Friedman test, what are the post-hoc analysis tests available?
So you such type of you have to check that through. If you are feeding then we will go for the pairwise to Wilcoxon sign rank test. Otherwise, if there are some, I think there must be some tests, postdoc tests there.
Nothing came when we were
Sir,
explaining.
I have a question, sir. So McNemar test, something like when we have paired sample and we have to compare proportions, there is something called McNemar test, because I did the research on twins once, and like twins, they are kind of paired samples. So when we compare proportions in the categorical data,
McNemar is that equivalent to that one. So if you are not, checking the median, if you are checking just the proportion, so McNemar will be applied there.
So, but what confusion today arose in my mind is that today I saw the name of McNemar here in the category of dependent sample to variable also. So it is something like Wilcoxon signed rank also. It means it is used when we compare means also. Then also we
for
can.
the two groups, if you are checking the testing the proportions, the McNemar you applied there. So
it is. So McNemar is for comparing the proportions, or McNemar is to compare the medians, means basically.
Not means are not compared there. Medians are compared there.
Yeah. So means and proportions both can be compared. That means by the McNemar.
Median and proportion.
Median and proportion. Okay, sir.
Sir, can you explain about Mann candle test, sir? Hello. Am I audible, sir?
Yeah. Just tell me.
Sir, can you explain little bit about Mann candle test, sir?
Which test?
Mann candle, sir.
Where it is? Mann candle. I am not right now recognizing it. Mann candle test.
Hello, sir. I am
Yes, sir.
Dr.
This is
Indranil Thakur.
No, so here since postdoc tests are not given, so we will be checking pair-wise different categories.
Okay, sir. Thank you.
Hello. Hello, sir.
Hello.
Hello.
Yeah. One by one.
Hello, sir.
Ask one by one. Yeah.
Hello.
Yeah.
May I
Just
ask,
tell
sir?
me.
Yeah, I have a question. I was actually analyzing few data of COVID. So what I saw that though my normality test, my sample was showing that it was a I should use a non. When I put both the tests, when I do both the tests, parametric and non-parametric, it is showing the same type of p-value. What should be the conclusion in such situation?
What is the sample size?
More than 500. 560.
Actually, you check first normality. You apply the normality test. If it is normal, then go for the parametric test.
Sir, I applied that, and it was showing that I was actually doing it in Jamovi. So it was showing that actually it was not normally distributed. Skewed distribution was there. So, but I applied both the type of test, parametric and non-parametric. But the p-value I saw that significant in both the type of tests. So can I use in that case any type of test?
No, you should apply in non-parametric only there. Maybe it may be since you are using a large data, so are all the parametric, non-parametric, and say all the test theoretical and all type of distribution approaches to normal distribution. Since you are using a big data, so the tests are of similar nature, the outputs are of similar nature, but you should use on the basis of the normality test only.
Okay. And then, sir, I was doing a CAP study on dengue. There I read a literature that bootstrapping, some method about bootstrapping. What is that actually, sir?
Bootstrapping is a resampling technique. Actually, we repeat the sample by fixing some sample size. So there are two famous techniques, resampling technique. One is jackknifing and the another one is bootstrapping.
Thank you.
How to do post-hoc test in like after chi-square test, post-hoc?
Pardon, ma'am?
How to do a post-hoc in chi-square test, like after you find the result are significant?
No need of, ma'am, no need of performing postdoc test there.
So like how to find?
If it is rejected, then it is not associated.
No, if it is significant.
If
then,
it is significant, it means they are associated to each other. They are
but
having
then
impact.
but then how to know which like type of education level? How to know which education level is significant in male and female, like undergraduate, postgraduate, like.
No,
So if the column is, sir, if it is a 3x3 table, I think her question is like, yeah, suppose it's a 3x3 table or 4x4 table, then if like it is significant, then which particular row or column is significant, how to get to know which one is significant?
So you check by reducing the columns, by reducing the rows. You can check.
But like I didn't get it.
You can check having two categories only. Then you increase 3, 4. Then you will be able whether it is going to be significant or not. But there is no, postdoc test for that one.
Okay, sir. I think there is no test probably for that.
Okay.
Sir, you said Sir, you in the last answer you said bootstrapping is to do resampling, but we already have a sample. We have done research on that.
Sometimes to get, ma'am, sometimes to get more
Please
effective
ask one by
sample size. Actually, to get the effective.
Yes, sir. Yes, sir. So how can, sir, statistics recalculate, like bring out the sample again?
You cannot hear, sir.
Yeah, please unmute yourself because there are so much noise, no? So we cannot.
Somebody was even playing songs, sir.
Yeah, so it's not possible to.
Okay. Suppose, ma'am, you are having 10 observations.
Yes, sir.
So we what we do in bootstrapping, we take the sample of same 10 observations by taking with replacement technique from these 10 observations, and we make different so many samples, and we say whether the estimate is going to converge any optimum value or not, and that is done in bootstrapping.
Then ideally, sir, bootstrapping should be done in every work.
Maybe if you are
Sir,
if you are
yes, sir.
sometimes
actually it's not possible to cover
estimates code.
It's not possible to cover all the concepts within the limited time. So we have another sessions also. So don't.
Okay, sir. Okay, sir. Sir, एक request. So there is one more request, sir. At the end, please. At the last area.
So while choosing between parametric and non-parametric tests, there have any relation between the population size, it's finite or infinite? Is there any something like that? For finite population?
Actually, the population or say sample or say population with the sample 30, it's supposed to be less than 30 is supposed to be small, and there we apply basically I mean that exact test. But for parametric and non-parametric, we have to observe for the normality only there. So I don't think there is concept.
Yeah, so I think normality is
right. So you have to check normality
first thing before applying any parametric or non-parametric. So if you're
So
normal, then go for
I
the
want to ask
parametric.
a question.
Yes.
Sir, actually, I was conducting a randomized control trial. So we have two groups of preterm babies. One group received DHA supplementation and other group did not receive DHA supplementation. And we are observing the growth of the babies at 1 month, 3 months, and at the age of 6 months. So here I want to ask that how can we apply repeated measures ANOVA comparing both the groups?
No, ma'am, not at all.
So what should we do, sir?
You can every month you can use ANOVA or t-test. T-test you can apply independent t-test for every month, and for the same group you can apply the repeated measure ANOVA.
Okay, so it will tell me that that supplement helped in weight gain.
Yeah.
Yeah. But I cannot compare it with the other group.
No, ma'am. If you wish to compare effect that one, so you have to compare at the same time. You take the observation on both the group and you apply the independent sample t-test.
Okay. Yeah. Thank you, sir.
Dr. Dharmendra, I think we should now.
Yes, we have to stop the today's session because I think it was a nice session. So yeah, thank you so much, sir, for covering all the aspects like parametric test and non-parametric as well. Thank you so much for your efforts, and I hope participants have enjoyed. So we request you kindly share this PPT with us so that we can share with the participants.
Definitely. Just now I am just emailing you and you share with the participants.
Yes.
And, so if you have any query, any question, you please.
Please, sir, share your email ID.
To the Dr. Yadav or Dr. Singh, and we will be answering the queries.
Yes, sir. You please share your email also so that participants are asking so that they can directly contact you.
Okay, yes, sir.
You just write in the chat box.
Dr. S. Yadav, sir.
Yeah.
Dr. Sushil Kumar Shukla is sir with us. winner of this workshop and from Sci-Fi Medical University.
All the great statistician present here.
Thank you, Dr. Sir. Dr.
Sir, good evening.
Good evening. Thank you very much. It was a nice presentation. I think participants might have enjoyed.
Definitely.
And learned many things.
So I think participants have got the email ID also, so they can directly contact you. And thank you, sir, once again for wonderful session.
Okay, thank you for listening me and giving me opportunity. Thanks to the organizers and both the collaborative institutions as well. And so we'll be meeting soon in some.
Yes, offline mode also. We can
definitely.
We can plan. So thank you all. Thank you all. Thank you. And
thank you.
See you tomorrow. Good night.
Okay, good night to all of you. Good night.
Good night.